Look at this creature. With its sprawling posture and massive dorsal sail, it looks like a dinosaur. But closely examine the skull and jaw. This is Dimetrodon, an ancient synapsid, a distant relative of modern mammals, not a true dinosaur. When we think about human evolution, we often visualize a short, simple timeline, an ape deciding to climb down from a tree and walk on two legs a few million years ago. But our actual history begins roughly 320 million years ago. It is a massive saga of survival, marked by global catastrophes and narrow escapes from total extinction. Every part of your modern body, from the types of teeth in your mouth to the way your thumbs bend, is a biological receipt from an ancestor who barely survived Earth's most volatile environmental collapses. Roughly 260 million years ago, the Earth's climate swung violently between temperature extremes. To endure this, a group of synapsids called the cynodonts had to extract more energy from every mouthful of food. Look at this jaw comparison. Instead of relying on a uniform row of reptilian spikes, the cynodonts developed a complex toolkit, specialized incisors for slicing, sharp canines for tearing, and flat molars for grinding organic matter. To handle the shifting environment, they also started generating their own internal heat. They became warm-blooded, sprouting a layer of insulating hair to trap heat against their skin. These adaptations were put to the test 210 million years ago, when dinosaurs claimed the daylight hours and established absolute dominance over the food chain. Our ancestors survived by shrinking to the size of modern mice, scurrying into the underbrush and becoming strictly nocturnal to avoid the giant predators above. Living in the dark and hiding in burrows meant foraging was dangerous for offspring. To nourish their young safely without leaving the nest, these early mammals evolved milk production. First, warm blood, then specialized teeth, and milk production emerged as reactive survival tactics, responses to the constant threat of freezing or being eaten. Then, 65 million years ago, a massive asteroid slammed into the Earth. The dinosaurs vanished, leaving behind a massive ecological void. With the giant predators gone, our ancestors emerged from the shadows. One group exploited the safety of the forest canopies, becoming the first primates. This primate skull shows the biological hardware required for life in the trees. To judge leaps between branches, their eyes shifted forward, creating overlapping fields of view that provided 3D depth perception. The environment shifted again between 7 and 5 million years ago, as a drying climate caused the lush forests of Africa to enter into environments that looked like this. A sweeping, open savanna, where swinging through branches offered no protection. To survive the tall grass, early hominins like Australopithecus began walking on two legs. Standing upright allowed them to peer over the vegetation and spot approaching predators earlier. Standing upright triggered a total physical reorganization. By walking on two legs, the hands were suddenly removed from the cycle of locomotion. Around 2.5 million years ago, the Homo genus appeared. Homo habilis used those freed hands to shape stone tools, and eventually Homo erectus used them to master fire. The loss of the forests forced us upright, providing the anatomical prerequisite for the tools and fire that would eventually fuel our cognitive expansion. By 300,000 years ago, Homo sapiens arrived. Cooking with fire made calories easier to digest, funneling a massive surplus of energy into a rapidly expanding brain. This energy surge supported the development of complex language, early art, and the intricate cooperative social structures that define our species. Take a look at these three skulls. They belong to Neanderthals. We were not the only humans on the planet, but our unique cognitive and social traits allowed us to outlast every other parallel species. Over 300 million years, we morphed from a sail-backed reptile-like creature to a nocturnal scurrier, an agile primate, and finally, a bipedal toolmaker. The modern human body is the final product of 300 million years spent navigating a planetary obstacle course.